Hello, welcome, Chemistry 11. Alright, so, Chemistry 11, it's going to be quite an interesting one. Basically, as you recall, previously in chemistry, I've been speaking, we just about started on doing some stuff, thinking about quantum mechanics and orbitals. So I'm going to start this one a little bit differently because I wanted to. I'll tell you one funny thing though is that the names of the orbitals, it was SPDF, and these mean sharp, principal, diffuse, and fundamental. And that was from early spectroscopy, alkali metals. And I was only speaking about. It's funny because I was looking at what I was going to talk about today, and it's like all the stuff I've been speaking about in the bloody electronics episodes. Well, I'm not sure of capillary action and moving the water from lower to higher. It's well, you never know if you've got a few different stopping points there. Maybe if you're going up from a valley up to a big hill. But yeah, one of the things, right? This is kind of like almost not really that relevant, but I wanted to speak about this because, to be honest, it's not. I just wanted to. It's just like a little bit of background about this sort of stuff. Electrons have got this thing called a dipole moment as well. I'm basically introducing like these sort of like very kind of they're quite advanced topics, but at the end of the day, I've watched a lot of like PhD guys, and I know that they love talking about dipoles. This is like the big thing, dipole. A dipole, magnetic one, not an electric one. Okay, so all right. So, and the thing about electrons, right, is that there's this dualism. All right, so that's opposed to monism in philosophy. And interestingly, this thing as well, it was like, are there two different substances? This is the question, isn't it? To be honest, I don't really do philosophy nowadays, but I just wanted to mention this thing. Are there two different substances, or is it like a different level of the same substance? So that's quite an interesting question. So all these things sort of like, there's a lot of parallels between physics, chemistry, and philosophy. I guess that's what I'm trying to say here. And one of the things we could say about the dualist nature of this is that electrons are I said it was in a cloud. I said it like this electron cloud. It's like wave-like. So it's like never in a single point. But wave-like. It's almost that feels like continuous to me. And then the discrete thing we could say is particle-like. It's like combinatorics here. This is what we like. Particle-like. Now here, like is not really. I don't like it. It was quite funny. But anyway, always an integer number of electrons. Because we said, all right, so that's the. Is there anything else I really No, to be honest, I just wanted to talk about it very briefly. Um, I just felt like, if we're going to talk about orbitals, we've got to talk about that. But yeah, so they've got like all right. So we worked out the and it's got a principal quantum number because we spoke about a principal quantum number being the number of shells, didn't we? So yeah, it's up to So it's 2, 8, and then yeah. So there's up to 2 in shell 1, up to 8 in shell 2, and up to 8 in shell 3. All right. I to be honest, I don't really want to go to shell 3. I just figure out shell 1 and 2 because that 18 number, I thought there were 3 in shell 3, but there's not. I think I must have been confused. Oh, I'm probably not confused, but I probably just got it. I probably just didn't write that correctly. So yeah, unfortunately, there's a lot of difficult pictures to draw here, which is not very good for me. And I don't really want to be drawing 3D pictures. I need to do something about that as well. Honestly, though, I probably won't need to bother about it because even though it seems very exciting at this point, realistically, it's not. It doesn't. It doesn't. There's not. It's not really. It doesn't work like that. All right, but what? Okay, but what did I say then? So there's no. So these are bands. It's like bands. There's no precise energy levels. I mean, with isotopes, it's different. So I don't see how it could be. And we said that S is 1 orbital. P is 3 orbitals. I almost actually want to use the actual terms for it: sharp, principal, diffuse, and fundamental. I feel like that would be worth knowing, and I think I can remember it. So sharp is 1 orbital, principal is 3. And I've already forgotten what D is. Remember what F is. F is fundamental, which is 7 orbitals. And D is diffuse. So, sure, sharpening. No, I can think of some of them as in like photo editing stuff. I remember that old photo technique where it looks like an angel or something. It's quite a nice one. All right, so yeah. Yeah, so and this is kind of it's almost like and I get a feeling the maths is probably like probabilistic. Yeah. It's the chances of finding that electron. So yeah. So S orbitals are said to have spherical symmetry. Oh, I actually I might have a pop at drawing it. So what you do is now keep in mind these do not have a border, but otherwise I wouldn't be able to draw anything. There we go, I think. And let's try and p orbitals. So there's only one. But I guess this could be like. I guess that is this one. It must be this one here. And then if we do it like this. So I guess so this must be like the X one, this must be the Y one. And then we've got the Z one here. Donut thing there. Ooh, I wonder where this thing is. I'll put it in anyway. Anyway, the p orbitals. I'm not going to draw the p orbitals. I think the s orbitals. That's enough drawing for one day. P orbitals, and there's p sub x. Oh wow, that was a terrible sub there. P sub x, p sub y, p sub z, with lobes. That's a weird word. I'm trying to remember what the earlobe is. Is that the bit of just flesh at the bottom of the ear? With lobes along X, Y, and Z axes. Okay. Yeah. So what was I going to say? So yeah, I will probably get better at this. To be honest. Well, I have to, really, won't I? Electrons are drawn. The orbitals are drawn. As having a boundary. Even though they're clouds, you know, at the end of the day, there is still, two there. So, yeah. But yeah, but so this enclosed anyway. Yeah, at the end of the day, I'm just going to be very colloquial here. So anyway, this encloses over 90% of the face, over 90% of the space where you can find one electron. Okay. Yeah, and like I've mentioned before, there's one sharp orbital, 3 principal orbitals, 5 diffuse orbitals, and 7 fundamental orbitals there. All right. Okay, and now key thing here. Any individual orbital can hold 1 or 2 electrons. There we go. But no more. All right, good. So okay, so I've got the principal quantum number here. So this is the first shell here. So yeah, I guess we're still just going up in the elements here, aren't we? Really. As a single orbital. So I guess if you look at what was it? Probably hydrogen and helium that are in here, maybe. I mean, it must be like that. I don't know. Maybe it's not, but I'll just go with that for now. Single. You know, when you look at them close up, it's what it looks like under an electron microscope, or a scanning electron microscope, or a transmission electron microscope. Of course, there's different types there. As a single, there's many more than that. X-ray stuff as well, and then you get the spectroscopic data. So you find a single s orbital called 1s. N equals 2 consists of s and p orbitals. In subshells, called 2s and 2p. All right, so there's no no p here. All right, you know, for the end of the day, you got to be a bit like this. All right, so equals 3 consists of sharp and principal and diffuse orbitals called 3s, 3d. Oh no, sorry, 3s, 3p, and 3d. All right. So yeah. Okay. Now the next question is, how can an electron? So how can an electron? How can an orbital hold 2 electrons that are repelling each other? All right, and he asked that. So the answer to that, spin pairing. I actually alluded to this at the end of the last episode. So you can imagine. To be honest, the thing that makes me think the most is like, oh man, I can't actually draw this, can I? I'm thinking of an. How the fuck do you draw an? Well, whatever. Octahedron reminds me of how it is, really. If I'm being honest, it looks like an octahedron. Yeah. So electrons possess charge and spin. So they're charged and they're also spinning around. And it looks like an octahedron to me. Yeah. So electrons rotate at a fixed rate. So no floating point stuff here, whatever that means. I don't know, probably is floating point as well. That knows. Okay, so we can visualize spin level rotation rate. 2 electrons. So 2 electrons exist as a pair. By having opposite spin. And it's fixed. And yeah. So clockwise spin. Denoted by up, and anti-clockwise. Spin. It's down.